Hello everyone, my name is Sahdev Zala. I'm a software engineer at IBM in Raleigh, North Carolina. I'm a project technical lead for two projects. Both are sub-project of OpenStack Heat, OpenStack TOSCA-Parser, and OpenStack Heat-Translator.
And I'm Bob Haddleton. I'm a solution architect and innovation team lead at Nokia. I'm out of Chicago, and I'm on the core team for the OpenStack Tacker project.
Thanks, Bob. So we will talk about deploying TOSCA NFV workloads with TOSCA-Parser, Heat-Translator, and Tacker. So basically, I'll be giving briefing about all those projects and about the TOSCA integration in OpenStack, and then Bob will talk about the architecture overview and how Tacker is consuming those both the projects, and some of highlights of the future development. So TOSCA-Parser, as you may know, there are two different TOSCA profiles out there, TOSCA Simple Profile in YAML and TOSCA Simple Profile for NFV workloads. TOSCA Simple Profile is more about general specification, whereas NFV Profile extends the Simple Profile for NFV specific need. TOSCA-Parser basically reads in the TOSCA entities, TOSCA node types, capabilities, policies, custom types, etc., and it produces an in-memory graph of those nodes and shows the relationship among them. And it's a sub-project of Heat, as I said. Heat-Translator is also a sub-project of Heat, and it's focused on TOSCA right now. It basically translates TOSCA into the Heat orchestration template. And Heat, as you know, it's an orchestration engine for OpenStack. OpenStack Tacker project, it's a mainstream project. It became mainstream this year, and it's a project for NFV orchestration. I'm not going in detail of this slide. It's more for reference, but one of the important enhancements we made in TOSCA-Parser during Mitaka release cycle is support for NFV. In Tokyo last year, we had a working session between Tacker and us, and as part of that discussion, we thought, hey, it's really valuable to have TOSCA-Parser extending support for NFV. Bob volunteered for the development contribution, and as those collaborative efforts, we now have the support available. We treat NFV as an first-class citizen, similar to how we handle the TOSCA Simple Profile. And based on the need from Tacker, we now takes input as in templates or as an YAML dictionary as well. Heat-Translator, again, this slide is more for reference purpose about the enhancement we made during the Mitaka cycle with two different point releases. But the main thing I want to highlight is the support for NFV translation. To the end user, the translation to NFV is similar to translating the TOSCA Simple Profile. It's translated, identifies the template by the version. And here I just want to take a minute to show the ongoing cross-project activities in OpenStack for the TOSCA work and its adoption in the community. As you can see, we are using Nova and Glance to find a memory, a flavor and image for user-defined constraints for host and operating system. We are having a really good momentum going on on the adoption activities. We now have a plugin for Murano available. We have an OpenStack client plugin out there for unified client. And just a few weeks back, we completed TOSCA integration with the community app catalog project. So now you can browse TOSCA templates from apps.openstack.org. The two main stakeholders in both the projects we have, Tacker project, they're using Parser and Translator, and they're also contributing. Bob is doing a lot of contribution in both the projects. And Open Platform NFV team is also using both the projects, and they're also contributing. Heat is what we translate to, and with the Heat Translator, there is an option to automatically deploy template as well. I will hand it over to Bob now. So thanks, guys.
Thanks, Sahdev. Sure. The way we integrated TOSCA-Parser and Heat-Translator into Tacker, the first thing we had to do was modify the parser to be able to run inside a server. The parser was set up as mostly a command line, either take the template from the command line or via URL. So the first thing we did was modify it to accept a pre-stored template in dictionary form. And then we modified the parser to support extensions. And the first extension, and right now the only extension, is the NFV template. But the framework is there. If other TOSCA templates TOSCA extensions come along, other TOSCA definition sets that extend the simple profile, they can be added as extensions into TOSCA-Parser. The translator itself has no NFV-specific code. All of the NFV-specific work is done inside the parser and inside the template. But we did extend the translator so that as you add custom properties to your nodes, those will get automatically passed through Heat-Translator and then processed into the hot template. That does mean, however, that we have to pre-process, if there's any properties in the nodes that Heat won't understand, we have to pre-process those out inside the Tacker server, and that's one of the things we do. So the TOSCA NFV translation support is invoked basically by just using the TOSCA simple profile for NFV version in your template. As I said earlier, there's nothing specific you need to do in translator, and it's basically just passing the either the YAML, VNFD YAML dictionary to the template, or if you're loading it in from a file, that's basically the two basic ways of processing an in-memory dictionary. This is just a sample. It's a bit of an eye chart, but it's just a sample of what a basic TOSCA template looks like for NFV. The NFV profile has things called VDUs for virtual deployment units. They use things called CPs or connection points, which is basically an OpenStack port. And they use what's called virtual links, which maps to an OpenStack network. So this is basically what a hello world, single server, single port, single network template would look like in TOSCA. This is just a quick overview of Tacker and where it kind of fits. If you're in telecom, if you've done anything with NFV, you'll recognize that picture. It's kind of a standard Etsy architecture of what the NFV looks like. And Tacker's trying to fulfill, the aim is to fulfill those two roles in the red rectangle, both VNF Manager and NFV Orchestrator. So how does Tacker use TOSCA-Parser and Heat-Translator? Basically, Tacker has a series of definitions, two different kinds of definitions. One of them is specific to functionality that's in Tacker, like monitoring, that is not NFV specific. And the other set of definitions are NFV specific extensions to the NFV profile. So if you look at the simple NFV profile where it defines things like VDUs and connection points and all that other stuff, Tacker then extended those to provide some additional functionality like monitoring and some other things that were missing from the original specification. Those two sets of imports are automatically added to your template when you deploy it in Tacker. The VNFD create process in Tacker, when you load the template in, will parse the template that you load in, given those two imports, to make sure it's valid. And then when you create the VNF, when you deploy your VNF template, again, it goes through and it reprocesses that template to do parameter substitution. It takes the graph that was stored in memory for that and hands it off. Does some pre-processing to remove anything that's specific to Tacker, things that Heat won't understand. And then Heat-Translator, the object is called TOSCA Translator, is used to generate the hot template. And then finally, Tacker will post-process that hot template and do things like add outputs that it needs, or do some property manipulation if it needs to, for example, to handle kilo properties versus Mitaka properties, things like that. So the future plans, Tacker's already planning to use things like policies and groups that have recently been added in TOSCA-Parser. One of the things that Tacker is doing is trying to stay both ahead of the spec and also implement the spec. So for example, the CSDO2 version that was available when this Tacker work was done had some issues that we had to workaround in Tacker, and that information has then been fed back into the spec process in Oasis, and those changes are in CSD03, which is supposed to be out real soon now. So Tacker can handle, both stay ahead of it and then implement those new changes as they come out. And then as those the new specs come out, we'll publish those changes into the TOSCA-Parser project so that they're supported there as well. Things that are coming along, network service descriptors for service function chaining, VNF forwarding graphs are currently in the works to be supported. And we're thinking about adding things like CSAR support into Tacker for the Newton cycle. That's about all we have. There is a Tacker. If you're more interested in learning more about Tacker, there's a presentation Thursday morning at 9:50, Ballroom E, I think, which is going to kind of a overview of the entire Tacker project and can give you some more details. Are there any questions?
Thank you, guys. Questions?
How does the service definition extensions you were talking about in TOSCA, how do you map those to specific implementation Heat stuff, like if you're using Juniper versus somebody else and you're using Juniper resources in Heat, how do you model that in TOSCA?
So
You could repeat the question.
yeah, so the question was, how do you model specific resources in TOSCA, for example, Juniper resources? So, and I'm not familiar, so you've got specific resources that were created for Juniper networking, I guess, for example. So those,
For example, it could be anybody else, right?
right. So those would have to be mapped. So Heat-Translator would have to know how to map to those resources.
So
Basically.
the answer is basically if there is a custom resource in Heat, right, which can be mapped, then we will map it to it, right? So we
Right.
basically have right now, for example, we have a TOSCA compute node which maps to the Heat Nova, right? So for any custom resource or custom node, if there is one Heat resource out there, we will map it. And that's basically, we go through all the resources. We have that mapping logic and a couple of algorithms there, which basically looks for those one-to-one or best mapping, right? If there is no mapping, well, we can do the
And how
mapping.
can you add the map if there doesn't exist?
Well,
Is
then
there like a
that's
plugin?
basically adding that as a feature into Heat. Creating
Also, as long as there's a Heat official or contributed plugin,
a
you support it?
plugin should work too, yeah.
Yeah, for example, just as a way to represent that, there's a vendor property on the virtual link. So the network has a vendor property that you could key off of when that's Juniper, right? You could go off and do specific things to map to Juniper resources. So it's certainly feasible to do it.
Yeah.
Okay? Thanks,
you, guys.
thanks very much.
Thank you, guys.